Okay, last lesson with the unit circle, but it's the most important lesson. Here's a complete unit circle. Includes degrees, radians, and now also coordinates. Now you can use this for a few days as a reference tool. All right, sort of think about it as your periodic table, but for trigonometry, the unit circle. Again, it's important to actually memorize this. I'm just going to briefly talk about some of these coordinates, and then we're going to get to the aha moment, the most important moment of the whole lesson. All right, so first of all, if I think of this first 30-degree angle, if I think about it as a right triangle, all right? So check this out. If I think about this as a right triangle, well, first of all, it's the unit circle, so its radius is 1, all right? This we're going to call x, and this we're going to call y, all right? According to trigonometry, if I want to find the value of x, all right, I am going to use, see if you remember, so, ka, toa. And that's a big leap right there. If I want to find the value of x, I can use so, ka, toa. In other words, right triangle trigonometry to find missing sides and angles. All right, so for x, because it's the adjacent side to this angle theta, because it's the adjacent and I know the hypotenuse, I would want to use cosine. Keep something in your mind that says x cosine, x cosine. We'll come back to that. All right, because we're going to say basically the cosine of 30 degrees, that angle is 30, not just theta. The cosine of 30 degrees should be equal to the adjacent side, which is x, divided by the hypotenuse, which is 1. In other words, the cosine of 30 is going to be the x value. All right, the cosine of 30 is simply the x value. All right, in which I have right here happens to be the square root of 3 over 2. Now, where did that come from? All right, if I would actually use Pythagorean theorem, you would see that square root of 3 over 2 quantity squared plus 1/2 quantity squared to give you 1 squared. So this is what we have found out. At the cosine of an angle, and really I can say theta instead of 30, right? Switching back and forth. The cosine of any angle is equal to the x coordinate on the circle, which we're going to fast forward and go ahead and say that the sine of any angle can just be simplified as the y coordinate. So if you're wondering, what in the world are all these coordinates for? Well, they're all xy coordinates, correct? Meaning that they're all representative of cosine, comma, sine. All right, they're all cosine signs. All right, that's what the coordinates mean. If that just flew right over your head, here's what it means. All right, in action. If I wanted to very quickly know the cosine of 60 degrees, all right, the cosine of 60 degrees for a math problem that I'm solving, all I would have to do is think about 60 degrees on my unit circle and remember that the cosine is the x value. In other words, the cosine of 60 is simply 1/2. All right. If I wanted to find something like the sine of 90, well, the sine of 90, I would locate 90 degrees, and sine is actually my y value. So the sine of 90 must be equal to 1. And you can verify all of these on a graphing calculator. All right. If I want to go more complex, like the cosine of 135 degrees, the cosine of 135 degrees, well, I would find the x value of a 135, and that's equal to negative square root of 2 over 2. That's a better answer than a calculator can give you. A calculator is going to tell you that that is negative 0.71 or something like that. But now, because you have an understanding of xy coordinates on the unit circle, you have now come to understand that the x coordinates, the x's of the coordinates are the cosine values of that angle, and the y's are the sine values of that angle. So that's what this whole unit circle was about. It was about getting its coordinates so that I can memorize and I can very quickly refer to sine and cosine values, or backwards, cosine and sine values. Once again, cosine is x, sine is y. All right, and that's how you use the unit circle with its coordinates.